Hi all, welcome back. And in this video, we are going to learn about Hasse's diagram. Okay, so here, whatever we have learned about poset, toset, associativity, and also the covering that will come into picture. Okay, so let's say we have a poset P, and this is a partially ordered relation defined on P, and this is a poset. So considering P and this as a poset, we have every element every element in P denoted by a circle just like this. Okay, and for every two element to x and y covers x. Now already we have discussed about y covers x means x is somehow associated to y, and x is uh, uh, has a partially ordered relation with some z, and z had some partially ordered relationship with some I mean this y, and it implies that either x is equal to z, or y is equal to z. Now first of all, x is has an associative relationship with y means x is has a partially ordered relationship with y, and x is not equal to y, and there does not exist any z such that x has a, partially relationship with z, and z has a partially relationship with y. So there does not exist anything in between. Okay, so this means y covers x. Now this can be represented in a much better way. I'll show you. So this can be represented like there is a y, and there is an x, and y covers x. Okay, or like this, and there is an x, there is an y, and y covers x. Or you can represent it like this: there is an x, there is an y, and y covers x. Now y covers x means it's y covering x means x has an associative relationship with y, and if there exists a z that has an associative relationship with x, and z has also associative relationship with y, then it implies that either x is equal to z, or z is equal to y. Now this means there does not exist anything in between x and y, right? So it's simply x is has an associative relationship with y. Sorry, has a partially ordered relationship with y, and x is not equal to y, right? So this way it is represented: y covers x. Okay, and the third thing is x has an associative relationship with y, and y does not covers x. If we say y does not covers x, so what does that means? This condition we are not implementing. Okay, so it can be something like there is a y, there is an x, and there can be a lot more elements in between them. Okay, so this condition, so x has an associative relationship with y, but y does not covers x. So there can be some middle elements like z, such that x is has a poset relationship with z and all. Okay, so now we'll construct it, and let's see how does it happens. So let's say we have a given as 1 2 3 4, and let's say a and less than equal to is a poset. So here if we consider, so this is somehow we can consider like we have 1, then we have 2, then we have 3, and then we have 4. So in this way we can construct this chain. Okay, so this is basically a toset chain. Okay, so for every two elements, for 1 and 2, 2 is covering 2 is covering 1, 3 is covering 2, and 4 is covering 3. Okay, so in this toset chain we can say that for 1 and 2, if we assume that for 1 and 2 and 3, so there is for 2 covers 1, and in this case 2 covers 1 and 3 covers 2. Okay, so we can write it like this, and in 1 2 3 4 we can say that 2 covers 1, then 3 covers 2, and 4 covers 3. Okay, so if we need to find out the number of lines here, so how many lines are there? So this is 1, this is 2, this is 3, and this is 4. Altogether total number of lines is 3. Now, how to get this number of lines? So either you can count it like this way, or you can write for each element. So if there are two elements, so 1 covers 2, so there is one line. Now for 2, 1, 2 and 3, so 2 covers 3. So already there is a line. So for 1 and 2, so there is one line for this. And if we have again 1 2 3 and there is one more element, so for this the line has been included, so altogether there are three lines. Okay, in this if we want to get the greatest, so the greatest is 1 to 4. Okay, 0 to 1, right? And if we need to find the max element in this line, so max is 4 and min is 1. Okay, let's see some another example. So let's say again we have the same set A, and it has now included 1 2 3 4 5 6 6 elements, and there is a poset A, and there is a division operator on A. Now here if we construct this poset for this, so we have 1, right? And we will construct this way, like we have 1, so 1 will divide 2, of course. So 2 covers 1. Now 1 divides 3. So we have 1 covers 3 covers to 1. And then we have 1 divide 4 and 1 divide 5. So here is 5 and 5 covers 1. Then we have 1 dividing 4 as well as 6. Okay. And we know that 2 also divides 4, so we can write this as like this. And we also know that 2 and 3 both divides 6, so we can construct 6 like this. Okay, so this is 6, right? And 1 also divides 6, so 1 is at the bottom. So this way is the Hasse diagram for this particular poset. And here if we want to find the minimum, so minimum is definitely 1. And if we need to find the maximum, so we have to just see what are the at the top. So 5, which is not covered by anything, so 5 is not covered, 4 is not covered, and 6 is not covered. So these are the maximum and this is the minimum. Okay, now if we represent 1, so 1 and 0 we are representing. So 0 means we are taking the minimum, so minimum is 1, and 1 is stands for the greatest. So here also I have already written that 1 is the greatest and 0 is the least. Okay, so the greatest refers to this max part, that is 4. Okay, and the 0 refers to the min part, that is 1. But here if you see, we have one minimum, that is 1, but greatest out of these three we can't find what is the greatest, so we can write here does not exist. Had it been be only one element, we can have taken it as the greatest, but there does not exist just one element, there are three elements, so we write it as does not exist. Okay, now if we need to find the number of line for this, so the easiest way to find the number of line, let's say this is the set of elements 1 2 3 4 5 6. Then first we will see 1 and 2, so 1 divides 2, of course. Then we have we will see 1 and 3, so 1 divides 3. Then we'll see 1 divides 4, but we also have 2 here. Okay, so just a second, let me write it line by line, uh, so that it becomes easier to identify the number of lines. Oh, why it's not working? Okay, now 1 divides 3, right? Now what we have all together, we now have reached 1 2 3. Now the next element is 4. Okay, so out of 1 and 1 2 and 3, 1 divides 4 and 2 divides 4. Okay, so we can write it like 1 and 2 divides 4. Now we have all together 1 2 3 4. Now we reach 5. So out of 1 2 3 4, uh only 1 divides 5, so there will be one line 1 divides 5. Okay, and then we have 1 2 3 4 and 5, and we have 6. So out of all these, what are the things that divide 6? So 1 divides 6, 2 divides 6, and 3 divides 6. So 1 2 3 divides 6. So altogether one line, two line, three line, four line, and five lines. So number of lines you can calculate like this also. Number of lines is equal to sorry 5. Clear? So this way we construct the Hasse diagram for a given poset, and we identify the min max, the greatest least, the number of lines, and we identify the diagram. So this was an easy diagram, but this way you'll get a more idea for this diagram. I mean, this diagram gives us a more detailed idea. Now let's see another example, and this will give a more elaborate idea onto Hasse diagram. Okay, so let's see that. Okay, so let's say we have this set of elements A that consist of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and we have A and division operator onto A. Okay, now we have to find out the number of lines, minimum, maximum, and so first we will construct the hash diagram. So let's say we have 1. Now one will divide how many elements? So one will divide all, right? First see the second, 1 and 2, because we can't consider also at a time. We will see 2. So 1 divides 2. Okay, now we have 1 2 and 3, so 1 divides 3. Okay, so 1 divides 3. Now we have 1 2 3 4, so 1 and 2 both divides 4, so we have 4 here. Now we have 5, so 1 divides 5. So 1 divides 5. Now we have 6. So 2 and 3 divide 6. So 2 and 3 dividing 6. Okay. Then we have 7. So 1 divides 7. Okay. Then we have 8. So 1, 2, 4 divides 8. So 1, 2, 4 divides 8. Okay, then we have 9. So 1 3 divides 9. Okay, so 1 3 divides 9. Then we have 10. So 1 2 and 5 divides 10. So 1 2 and 5 divides 10. Okay, this way, and here is this 10. Now from here only you can say number of lines is, you can just count 1 2 3, 1 2 3 4, 5. Okay, 6 7 8 9 and 10 and 11. Okay, so number of lines will be 11. Okay, or you can count via that approach. Now you have to find the max, so just see what is not covered here. So not covered is 10, 8, 6, 9, and 7. Okay, and the min is nothing but 1. So this is the minimum. And if we have to find the greatest and the least, so 1 stands for greatest and 0 stand for least. So greatest, of course, it does not exist because we have a lot more elements, more than one element in the max. So we write greatest does not exist, and the least is of course 1. Okay, so this way we define the hash diagram for division operator onto this set. And this is a smaller one. I mean, this is a smaller set. So this is the hash diagram for this set. And this is a very simpler one. So it is the hash diagram for this set. Okay, let's see a complex one like D24. So D24 means all the divisors of 24. Okay, so 1 2 3 4, 6, 8, then 12, then I think it is 24. Okay, so these contains the divisor of 24. Now this is onto this you have to construct the hash diagram. So first we will take 1. Okay, now then we have 2, so 2 covers 1, I mean, so this, right? Now please note that here we are taking this operator as divisors. Okay, so we are taking the divisor operator. Okay, so you will learn this part. So let's take 3. So we are not seeing this like 1 divides 3. Okay, I mean 1 is a divisor, we are taking 1 as a divisor of 3. Okay, so 2 is not a divisor of 3, we won't take. So 1 is a divisor of 3, so we are taking 3. Now you will see, find the difference, that's what I'm saying. So for 4, so we are taking like something like d4. So for d4, 1 will be get there, 2 will be there, and 4 will be there, because all these are divisors of 4. Okay, so if we write 4, so this is 4, 1, 2, and 4, so this is 4. I think I need to construct the diagram in a much cleaner way. Just a second. So this was 1, this was 2, and this was 4. Okay, and this is 3. Okay, now we have 6. Now you have to calculate d6. See, there we were having division operator, here we have d 6, right? So for 6 it is 1, 2, 3, and 6. Okay, so for d6 it will be 1, 1, 2, 3, and 6. So this will come like this way. Okay, so somewhat here, 6, right, this way. Now we have 8, so for d8 we have 1, 2, 4, and 8. So it will come 1, 2, 4, and 8, right? Then we have 12, d12. So for d12, 1, 2, 3, 4, and 6. Okay, and 12, of course, 12 is a divisor. So 1, 2, 3, 4, 6, and 12. So 1, 2, 3, 4, 6. So altogether we have like this 12, right? And then we have 24. So for 24, what will be the divisors? 1, 2, 3, 4, 6, 12, and of course 8 is also, right? So yes, so this will construct like this. So here is our 24. Okay, this way. So this is the diagram. We can construct more cleaner diagram, of course. So yep. So this is the way we construct the hash diagram for D24. Now here, if you see, if you need to find the number of lines, of course, number of lines will be number of lines. Either construct or see via writing it down. Okay. So number of lines will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so number of lines will be 10. Now max, if you want to find, so max includes what is not covered, and that is of course 24. And min, if you want to find, so min is nothing but 1, because this is the lowermost element which is covered by all the elements. Okay, and then you have to find the maximum, greatest and least element. So greatest will be 24 and least will be 1. Okay, so for d24, this is the hash diagram, right? Similarly, we can construct for any diagram. So we will be learning about what does this greatest and least means, and what is about upper bound and lower bound. Let's see one or two more example on to hash diagram, because this is a very important topic. So let's say we have a set, and the set contains elements like 1 and 2, and we are defining a power set S, and then we are defining a subset operation. Now we all know that this is a poset. Okay, now for this poset we can construct the Hasse diagram. So power set of S will include elements like 5. It will include 1, 2, and 1 and 2. Okay, so this is the power set, and we are defining this operator onto this. So for every element we can check whether it covers another element or not. So for 5, if we check 5, so here is this 5. So 5, for 5, 5 it has is comparable to this 1. Okay, so if we represent it like this, so this covers this one. Now if we take 2, so 5 has 5 is comparable to 2. I mean 5 is a subset of 2. So we can write this as like this. Okay, then we have 1 2. So 5 1 and 2 all are subset for 1 and 2. So we can write like this. Right, so we have this Hasse diagram like this, where a number of lines will be 4, and from here we can calculate the max as 1 and 2. Okay, and the min as of course 5, and if we have to calculate the greatest, then the greatest will be the max, that is 1 and 2, and if we have to calculate the least, then that is equal to 5. So this is for this particular poset. Let's say we have another poset like this. Let's say we have S as given as 1 2 3. Then power set of S will be 5, then 1, then 2, then 3, then 1 2, then 2 3, and then 1 3. Okay, and then 1 2 3, all the 8 elements. And if we define a poset such that subset operator operation is defined on P of S, then for this poset, if we have to construct the Hasse diagram, so how will be constructing? So we will see, start with phi. Now phi is comparable to this one, phi is comparable to 2, phi is comparable to 3. Okay, so this one, so 2 and 3. So 5 is comparable to 1 2 and 3. Then we have 1 2. So for this, if we construct, so for 1 and 2 we can construct like 5 1 and 2 are the subset for 1 and 2. Okay, for 2 3 we can construct like this. So for 2 3 it will be 5 2 and 3. Okay, and for 1 and 3, okay, 1 and 3 can be constructed something like this. Okay, it's getting very dirty, but you just understand the flow of my pen. Okay, so this is a 1 and 3, right, this way. Now for we have now 2 and 3, 1 and 3 all included. Now we have 1 2 3. So for 1 2 3 it will be like this, all including on into this. So like this, something like a cube. Okay, so this is 1 2 3. Now here, if you have to calculate the number of lines, so number of lines will be the lines of the cubes, that is equal to so altogether 4 4 8, I think it's 12, right? So it's 12, and the maximum is of course 1 2 3, and the minimum is 5. Okay, and this maximum is also the greatest, and minimum is the least. Okay, so this way. Now considering these two examples, let's say I have another example like S, and S includes 1 2 3 and 4, and it we are defining a poset on S like this. So here, if I ask what is the max, then of course you can write it like what is the max or the greatest. You can write it like 1, 2, 3, 4, right? So no need to write everything, and you can write the min and the least as 5. Okay, and also you can calculate from here the number of lines. So number of lines will be, first time it is 12, then 2q, and then 12. So how it is coming, I'm just telling you. 24 plus 8, that is 32. So 12 means 2q means altogether we are calculating like if we have a cube, so altogether we have 12 lines, right? So how does it happens? So first of all, we are calculating for each base. So there will be how many base, and then we will be calculating for the number of side walls, right? So this will give us side walls. So this is how we calculate the number of lines. And that's all about a hash diagram. So these are some of the examples that we discuss on to hash diagram. Next we are going to see about some of the special elements like max and min elements, and least and greatest element that we just now discussed. And then we will see about the upper and lower bound. So all these are related to hash diagram. So let's go ahead and see that part. And for this, if you have any comments or question, then please do post in the comment section so that I can answer those questions. So thank you very much and keep watching.